Module 1, the 7 testing principles. Now that we learned what testing is and why it's necessary, the next thing to do is understand the different principles applied to testing. So to learn this, we're going to walk through an example together. Our job is to test a sign-up flow for a new email account. You can see our mobile application here has 4 input boxes: name, email, password, confirm password, and submit. This form is used to sign up for a new email account on our fake website. So the first principle is testing shows the presence of defects. So looking at our application and testing the sign-up flow, you have the ability to expose if the defects exist. So this will reduce the overall chance of defects going unnoticed in software. However, testing the sign-up form by itself cannot prove that the software is free of errors. It is highly important to create test cases that are targeted at finding as many bugs and defects as possible. So for instance, if you look at the 2 options for test cases provided below, notice that one set focuses on just letter case scenarios, where the second set focuses on 3 different areas that could find defects. As a result, the second set would be the best option for trying to find as many bugs as possible. Again, the one on the left, we're using lowercase, uppercase, and mixed letter case scenarios, but really the only thing we're testing is case sensitivity, whereas the option on the right, we're going through a happy path scenario, making sure everything works as appropriately. We're going to go ahead and try using an invalid email format, which will test our email validation. And then we're going to try testing a password that doesn't match, which will test our password matching validation. So we're testing multiple areas with the second scenario versus the first scenario. We're only testing one area. They're both great test cases, but the one on the right is the best for finding defects in this scenario. The second principle is exhaustive testing is impossible. Think about what types of tests you can perform on the sign-up form. Having 4 input fields, it might seem like a simple task at first, though there are so many different values you can enter for a text input field, it would require so much time and money to try every combination. Let's say for instance the input box for name allows just 10 characters. And those characters are only letters. We don't even allow percentages or dollar symbol or alt characters. Only the 26 letters in the alphabet. So using the combination algorithm, you can see 26 letters over 10 different combinations results in over 5 million different possibilities. That's just one input box. If we took that across the 4 input boxes, we would be here forever. So to clarify, with the exception of very, very simple applications being tested, it's nearly impossible to test every scenario. On account of that, risk analysis, testing techniques, and test priorities should help guide the areas you're going to target. The third principle is test early. The earlier you begin testing in software development lifecycle, the more time you'll have to find defects. Additionally, it costs far less to find the defects early in the process rather than later. In our sign-up flow example, it would be wise to test this sign-up form as soon as it's ready, rather than waiting for it to be fully integrated with an entire system. Once it's integrated with the entire system, there'll be some additional types of testing to perform, but you can find defects with the form itself earlier in the process. For example, when the UI is ready, we can start testing the validation from the front end. We don't need it to be connected to a back-end system where it's inputting the emails. So again, testing early saves time and money. The fourth principle is defect clustering. Majority of software issues will be related to a small number of software modules. We can closely look at Pareto's principle that goes further into how 80% of the problems are caused by just 20% of the modules, often referred to as the 80-20 principle. These 20% of modules are the ones that should be highly considered during your risk analysis. The fifth principle is pesticide paradox. When insects are attacking a garden, pesticides are used to fight these species off. After repeated use of the same pesticides, the insects start developing resistance to these pesticides. The same idea will be used in software testing. Certainly, when testing a system If the same tests or test data are repeated and used over and over, the tests start to no longer have a meaningful impact. It's important to change your test cases and test data up over time. Regression testing does repeat test cases over and over in that type, but this type of testing will be explained in a later tutorial, and it does have benefits of repeating in that case. As a result, though, it's still strongly recommended to rotate test data through your test cases during regression. The sixth principle is testing is context dependent. While performing testing, it's important to keep in mind that the industry, the goals, and the need for the software differ from place to place. The way testing is performed in one area is not the same way it will be performed in another area. Testing that's done for software that monitors a patient's heartbeat during surgery versus software that detects nearby cars in a Tesla versus software that generates cats memes are all going to have different testing ranges, difficulty, and priorities. In some industries, software will be completed in a waterfall fashion, and in others, a more agile fashion. Going back to our sign-up form example, if our sign-up form was used for a bank account versus our weekly cat meme newsletter, the priority of executing test cases for this form is going to be different depending on your risk analysis for each industry. The bank industry is going to want to make sure that email sign-up form works flawlessly. You're not going to want to give somebody's bank information to somebody else. Versus a newsletter, if you accidentally send an email to somebody with a newsletter in it, it's not the end of the world. The seventh testing principle is absence of errors is a fallacy. It is a common misunderstanding that when testing is completed, all defects are fixed and requirements are met that software is ready to be shipped. Remember that just because there are not any errors in the system or defects open does not mean the software is ready to ship. In fact, testing is only part of the software development lifecycle. There are many other areas that need signed off on as well. For example, in our sign-up flow, there could be no defects, all test cases are completed, and all requirements met. The developer, though, could have designed a very poor user experience using a hard-to-read color scheme. This surely would not make a successful software launch. In summary, these are the 7 testing principles and guidelines that you should perform whilst doing software testing.